Okay, so now let's go through. So we've gone through what 1-step and 2-step communication. So let's go through our little examples here and do these questions. So using the diagram shows the communications within a group of friends in below. Okay, use a matrix N to record the presence or absence of direct communication. So all they're saying here, when they say direct communication, just write in there that what they're asking for is they want the 1-step communication matrix. Okay, so sometimes we need to write, because if they word things different, so they essentially want you, but they want you to call it N. So that's okay, so we'll do that. So part A, we normally, when we're explaining it, we call it matrix C, but they want me to call it matrix N. That's fine. I'll do that. So I'm going to create a 4x4 because I'm going to have Vicky, Stephen, Kathy, and Paul. Now, this is where I'm telling you, because I've done Vicky first, I've got to do that way. So Vicky, Stephen, Kathy, and Paul. Just say, for example, you did a different order. That's okay, as long as can you see that your order is the same across and down, okay? All right, so the link between use the first letter of each name, we did that, and let's record it in and explain how the matrix can be read using labels. That's okay. Let's just write up the matrix. Okay, so Vicky's they're not going to talk to themselves. So generally we see a 0 down there. So I put that in. Then I have a look at Vicky. Can Vicky talk to Stephen? Yes, she can talk to Kathy, but she can't talk to Paul. Stephen can talk to Paul and can talk to Kathy and also can talk to Vicky. Can talk to all of them. Kathy can talk to Vicky, Stephen and Paul. She can talk to everyone. And Paul can only talk to Stephen and Kathy and put a 0. So there's our thing. So we've done that. We've recorded it and explained how the matrix can be read. So you can just say, let's just look for an example. So you might just go, if you go across here, and we'll just write out that Paul can speak directly to Stephen and Kathy. There, we've explained our matrix. Okay. Why is the matrix symmetric? So what do we mean by symmetric? If you have a look here, so when they say, why is the matrix symmetric? Remember, symmetric is if you put a line down there and you thought it was a mirror, does it produce the same on each side? Just say you're looking in the mirror. Does it see this? Does it look the same on each side? It does. Why do you reckon it's symmetric? What do we think? If I can talk directly to Sebastian, they're saying on the arrow he can talk directly back to me, isn't it? So that is why, because if it can go one way, it can come back the other way. So why is the matrix symmetric? We'll just say that because the communication between two people goes back and forth. Because communication between two people can go both ways. Let's just say that. All right. So if you want to just put a little example, you could just say Vicky to Stephen can go Stephen to Vicky. Okay. That's all right. If you just try to explain what you're doing. Sorry, we're running out of a little room. Okay. What is the information given by the sum of K? So if we look here, what's the sum? Did it say the row of column K? So if you add up column K, it equals 3. So what does that mean? What does that mean? If we could, so who was K? Kathy. So Kathy can talk to 3 people. Okay, that's what the sum of 3, the column means. Okay, it says now n squared gives the number of two-step communication between two people. So that's right, we said that. So namely, how many ways one person can communicate with someone else via another person. Find the matrix n2 at the square of matrix n. All right, so we're going to do that. Okay, we have got to put, they're asking us to find the n squared, which is a two-step communication. So we're going to go into our calculator on a normal calc page. And what we're going to do is first we have to put in matrix n. So matrix n was a 4 by 4. So remember, we click this one, and I'm going to do 4 by 4. And then I'm going to type in what we had. So we had 0, 1, 1, 0. Okay, so we're quickly typing. This is n. Okay, and so this tells us one-step communication. All right, so oops. So once I've done that, I just press enter. Now, what I want to do is get the n squared. So all I need to do is go up to that. I'm pressing the up key, highlighting it, and then I'm going to square it. I can either press the square button or you can raise it to pad 2. So press square, press enter. That is now n2 there. So if I pop that in our notes, sorry, it'll be a little bit small, but here is, this is over there is n2. So okay, so we've done n squared, and then the next thing they're asking us to do is, they said, so we've done that. All we did was pop in the n matrix, raise it to pad 2, and then we've written it out. It says use in E, it says use this to find the number of two-step ways Kathy can communicate with Stephen. So if you look, Kathy was my third row and Stephen was my second. So here is, so find the number of two steps Kathy can connect. So how many is it? Yep, I just found it there. So that was 2. We've found it in the green highlight. Then if in the n squared matrix, there is a 3 where the S column meets the S row. So let's go, just highlight that one. So here they're saying with S and S, no, what did they say between S, which was my second number? So they're talking about this number 3 there. Explain how this can be given, how this can be a sensible interpretation. So this is that there's 3 two-step communications. So if you go back here, if you look, it's sending a message back to Stephen because S to S. So here's one option. Actually, no, what do I want to do? So it would just be sends to Paul back to Stephen, or you've got 1, 2, and 1, 2. So really it's just sending the message out to them and then back. Or Vicky, yeah, like that, okay? So it's really just sending them replying back. So when it says, explain how this is a sensible interpretation. So really that's all it is. They're sending a message, the same message back. Okay, we had to first record the one-step communication, and they said call it A. So I called it A. I've done the one-step communication and I've typed it out there. B, it says explain why it's symmetric. Because they directly can talk to and fro back to each other, you're going to see symmetry in the matrix. So what information is given by the sum of the column or the row? So it doesn't matter if you go across or you go down, it's going to tell you how many people that person can directly talk to. So if I went down the column of K, I can see there's 3. So that means if I added them all up, that means like Kate, can talk to 3 people, which is true. Okay, find A squared. So what I've done over in the calculator over here is I've popped in our first A matrix, and now I'm going to square it. So here is what we're saying a squared is, and then I would write that one out. So 3, 1, 0, 1. So I'm just copying that out. That's how you get two-step communication. You square your first one. Okay, and then the last question, using the matrix A squared, find out how many ways Matt can communicate with Kate and write the connections. So I'm going to go between Matt and Kate. So that's my column 2, row 1. So I've got only how many ways that Matt can communicate and write the connections. So it says using A squared. So if you look at it, there's 2 steps. So what we're going to say is Matt can go from someone else to Kate. So could Matt go to Will to Kate? Yeah. So we could do that, and there's the 1-2 step. And then obviously Matt could directly talk to Kate as well. So that would be the 1 step. So this is 1 step, and this one is the 2-step option.
Yeah, the 2-step, you just power the matrix by 2.
Yes. It's 2-step. All right.